So example 6 here. Oh, by the way, I like this question, I like this question, I like this question. Find the tension in the rope. This is a classic physics question because it turns out this method can be adapted not just to a tension in a rope, but it can be adapted to the force from an elevator. It can be, you know what, lots of stuff goes up and down. So what does this question want me to find, Andy? Okay, this is a job for a free body diagram. Look at the picture. Is this mass accelerating? See that wonderfully drawn arrow? Thank you. Which way? Okay, let's do a free body diagram. How about let's do it, oh heck, right next to the mass, right here. What are the forces acting on this mass? Get the obvious one. Too slow. What are the forces acting on this mass? Get the obvious one. Gravity. When I say that, that's your first thought. So you ready? What are the forces acting on this mass? Get the obvious one. Which way? Okay, so I'm going to draw an arrow pointing down. And now I'm going to actually just label it as mg. I think the first time I did F with a little subscripted g, but Megan, we can go one step further and actually throw the equation on there and save ourselves one step of brain thinking. Is this mass in free fall, Andy? Then Newton's first says there has to be another force acting on it. Which way is this mass accelerating, up or down? So the force pointing up is bigger, smaller, or the same size as gravity? Bigger. I'll exaggerate it just so that, because I don't want to later on look at my picture and say, oh. Which force is that? It's the rope. And we have a special name for the force of the rope. Begins with the letter T. Loud and proud. There's my free body diagram. We're ignoring air resistance and stuff like that because that's yucky mess. So just to jog our memory, here was our approach. You can write this down. We said we're going to go winner, takeaway, loser equals the net force. This was our template. This is not on your formula sheet, but you will end up memorizing it, and it's not too tough for one to memorize. You know, oh, winner, takeaway, loser. Yeah, a loser should be taken away, or whatever you want to come up with, right? Who's the winning force, Andy? Minus. Who's the losing force? And F net is always MA. You okay with that? Matt, what did this question want me to find? The T. How would I get the T by itself? How would I move this over? Ah, thank you. See, by the way, the real reason I showed you the formula manipulation stuff at the beginning of the year is I cannot possibly, Trevor, teach you every single force equation because I don't know them all. But what I can teach you is how to get whatever you need to get by itself. Add it. Isn't that nice? So if I hear you correctly, and I think I do, you're telling me in this situation, the tension is going to be MA plus mg. Did they give me the mass? They told me M. No, oh, by the way, now I always do a check to make sure I know everything. So did they give me M? Did they tell me A? Yeah. See in the picture? Yes. Did they give me M? You already said that. Do I know G? And I'm not going to put a negative in for G this time. Can you see? I snuck the negative in right here. Actually, right here. So I don't need to worry about that. I've taken care of direction. Now it's plug and chug. It's going to be, the tension is going to be 12 times 2, was it 12? Yeah. Plus 12 times 9.8, which is what? Oh, I might be able to do that in my head. It's going to be 12 times 11.8. 12 times 11 is 121. 12 times 0.8 is going to be 131.6. No, I'm off. Am I close? 41 point. Ah! Forgot to carry the 1. 141.6. So I'll go 141.6, and you know what? I'll go to 3 sig figs. I'll say 142 newtons, but I would take 141.6. And it's a force, so sorry, I should have paused and I said it's a force, units, and you all would have said newtons. Okay. Before you turn the page, Courtney, that's okay, but well, I'm going to stay here. What I'm really saying is, as far as I'm concerned, if I can give you a situation where this equation exists, I can ask you to find for tension or mass or acceleration. I can ask you to get any of those by itself. Let's keep going. Example 7, find the tension in the rope. Isn't this the same question, Mr. Duke? Not quite. And the 1 sec, by the way, the other reason I'm going to make you draw free body diagrams is the more you draw, the faster they get. And by the time you get good at this, Alicia, it should be 1 second to draw a free body diagram. And in terms of bang for your buck, it's one of the best 1 second strategies I can give you. So you ready, Alicia? We're going to do this one together, you and I. I'm going to represent the mass with a dot. There it is. You didn't put the mass on the same side, the same level. You know what? I'm just imagining it by itself. What are the forces acting on this mass? Get the obvious one. Which way is this mass accelerating? Is it in free fall? And I'm going to say no. Do you know how I know? Because if it was in free fall, what would that acceleration be as a number, folks? No, if it was in free fall, what would the acceleration be as a number? 9.8. Okay, right? See, we're building on stuff we already know. We just didn't know we knew it. So is it in free fall? So there has to be a force acting up. That's really what Newton's first says. There must be something slowing it down a little bit. Which way is it accelerating? So is the force pointing up bigger, smaller, or the same size as gravity? Which way is it accelerating? Who's winning? Down. So is the force pointing up going to be bigger, smaller, or the same size as gravity? Yeah. Because which way is it accelerating? So that has to be the winning force. You okay with that? So I'm going to say, yunk. I'll draw it significantly shorter. That's supposed to be an arrow on. It didn't really work very well. Let's try that again. There we go. Which force is that? The rope. The rope. What do we call the force from a rope? What you're feeling right now? Yes. My template, and you can write this down. You know what? Let's write this down one more time in our notes. My strategy is always going to be winner, takeaway, loser. That's what gives me the net force. Alicia, see my free body diagram? Who's winning? And really what I'm saying is, which has the longer arrow? Right? Who's winning? Can you give me the little equation, the 2 letters? Yep. By the way, you'll notice this time, Lydia, I found it much more convenient to let gravity be positive. Yeah. It's just mathematically much nicer to have the winner positive and less crap to deal with. Who's losing? And that's going to equal MA. Because F net Haley always equals MA. You okay with that? What am I trying to find, Alicia? I want to get this by itself. Yes? How? What's right in front of the T? So how could I move this to that side? Here's what I'm going to do. I'm just going to draw an arrow pointing like that. That's my way of saying I moved it to the other side. If you want to, you can go, I have no problem with that. Now, can you just imagine there's a little plus T right there? Can you I'll draw it in, but can you imagine it? I also need to move this MA to the other side because I don't want MA plus T. I want T by itself. You okay with that? How will I move the MA over? What's right in front of the MA? A positive sign or a negative sign? It's invisible, so it must be a. So how will I move the MA over? So here's my challenge. Are you guys okay if I do this in one step just by drawing 2 arrows like that? Is that you okay to follow that? You can show more work, Jess, if you want. But this is you may have noticed I tend to abbreviate. Like I always look for organized, but little writing. So if I hear you correctly, Alicia, here's what you're telling me. What would drop down like a domino? Which one haven't we touched at all? And then you're telling me there would be a minus MA attached to it? Yes? And the tension, we've moved to that side? Have we got the T by itself? You're allowed to smile now. Okay. Now it's plug and chug. It's going to be, quickly before we go, did they tell me M in the question? Did they tell, G, I know. M, you raised it. Did they tell me A in the question? Okay. So it's going to be 12 times 9.8, take away 12 times 4.2. Mr. Duick, the 4.2 is down. Shouldn't it be negative? Courtney took care of all of that with my winner minus loser approach. This time I found it easier to let down be positive. and up. Well, anyways, it all took care of itself. Do that one in your head, Mr. Dewick. 9.8 take away 4.2 is 5.8. Take away 0.2 is 5. 12 times 5.6. Maybe. 616. I'm going to go with... I'm off. What do you get? 60. 60. You know what? I carried a decimal over in the wrong. I was 600. 67.2. 67.2, is that what you said? $67.2 what? Newtons. Put your pencils down, look up. Gonna scroll back. You guys stay where you are. Or do you have both these questions on the same page? Okay, I'm gonna scroll back. You guys just stay where you are. Notice that when we're lifting something, when we're accelerating something upwards, tension is given by gravity plus mass times acceleration. Notice when we're lowering something downwards, tension is given by gravity minus mass times acceleration. When is the rope more likely to break? When you're raising something up or when you're lowering something down? Connor? Why? Because both of them have gravity in them. I can't get rid of that. But when I'm raising something up, I'm adding the mass times acceleration to gravity, which makes tension bigger. When I'm lowering something down, I'm subtracting the mass times acceleration. And don't memorize this. You can get it in 1 second from your free body diagram. It's not worth trying to file away in your brain. But for what it's worth, we've just proved if you ever watch crane accidents, the vast majority of them occur while they're lifting it up, while they're accelerating it up, not while they're lowering it. Lowering it, they're not too worried. Little nerd trivia. Example 4. It says, find the tension in the rope if the mass is moving up at a constant speed of 3.8 meters per second. Ryan, what does this question want me to find? Okay. You know what? Did they give me a picture? Rather than represent the mass separately with a dot, let's actually just label our picture. I'll let you do that. So I'm going to go like this. There. What are the forces acting on that mass? Get the obvious one. Definitely mg down. Okay. Should I draw tension bigger, smaller, or the same size as gravity? I'm not sure. Well, which way is this mass moving? What direction is this mass moving? Let's guess that tension is winning because up. So I'm going to draw a little longer arrow. I don't know. Okay. By the way, we're not right, but here the beauty of a good free body diagram is it will correct your errors along the way. So who are we guessing is winning? Tension. Who's winning? What we just said. Say it again. No. Who are we guessing is winning? So who's winning? Same answer. So my equation is going to be winner minus loser. Winner. So now, because you said tension is the winner, in your picture, who's the loser? Sorry, I didn't mean to say that quite at you. Who's the loser? Gravity. Minus gravity. And that equals MA, F net. By the way, Lindsay, you're okay? I skipped the English step of writing out winner minus loser, and F equals F net, and I've gone straight to the winning force minus the losing force equals MA. Now, Ryan, I love the fact that you twigged on the key phrase. Everybody, if you haven't underlined that, I would. Because what does constant speed tell you? No acceleration. As a number, what's the acceleration? It tells us that. You okay with that, Ryan? What's 10 times 0? What's 1,000,000 times 0? What's mass times 0? So if I hear you correctly, and I think I do, you're telling me... Yes? How would I get the t by itself? I would most definitely not subtract it over. What would I do instead? Especially because what's on the other side? A 0. So what's 0 plus mg? Just plain old? Oh, I like that. And you know what you've really done? You've proved that it's a tie. You've proved that I should have drawn tension and gravity the same arrow length. Remember you said, I'm not sure. And I said, well, you know what? Let's guess wrong, and we'll let the physics tell us if we're wrong. Here the physics is saying to you, tension is exactly the same size as gravity, which is true if you're not accelerating, Courtney, whether you're moving up or down at a constant speed. If you're not accelerating, then there's no net force, then everything's balanced. This is Newton's first law, because I said Newton's first law doesn't say that objects at rest have no net force. It says objects with no acceleration have no net force. The forces are balanced. 12 times 9.8. 12 times 10 would be 120. So it's going to be 120, take away 2.4. It's going to be 117.6. Double check me. Whew, I was a little worried. I was in a slump here. I had to get my 117.6. You know what? I'll just go to 4 sig figs, sure. I think in your homework, by the way, in the answer key, though, I'll do sig figs right. In other words, for here, I probably would have said, well, Matt, how many sig figs is that right there? How many sig figs is that right there? I probably would have said 120 newtons. So kids are all, Mr. Dewick, I didn't get the same answer. You did. It's just, if I don't think about it consciously, I'll go sig figs properly in my answers if I'm making an answer key really quick. Okay, just letting you know. Is that okay? So we can do a lot with this notion of a free body diagram. Hey, example 5. I said to Courtney, as far as I'm concerned, really anything in these equations is fair game to find. The other one that's going to be by far the most common is, suppose the cord tension is measured at 98 newtons. What's the acceleration? Okay. You know what this is a job for? A free body diagram. Although, since they gave me a picture, I'm going to be really lazy, Haley, and I'm just going to put the forces right on this picture. Haley, what are the forces acting on this object? Get the obvious one. Can I go mg if that's okay? Is this object in free fall? I don't think so. So there must be another force. What's the other force acting on it, Haley? What's the other force that's been acting on? Oh, by the way, can you all look up? I forgot to label this force here. I really should have. So if you didn't, put a T next to that one. And that's your hint. What's the other force acting on it, Haley? That was your hint right there. What's the other force acting on it, kiddo? Tension. Like you were feeling right then. Okay? Up. Who's winning? Oh, wait a minute. Haley, did they tell me how big tension is? 98 newtons. On your calculator, could you calculate very quickly how big mg is? It's going to be 12 times 9.8. Or if you're really lazy, Matt, you could just go 12 times 10. Rebecca, what's 12 times 10? So gravity's roughly 120. Haley, how big is tension? How big is gravity? 100. You know, what's bigger, tension or gravity? Who's winning, tension or gravity? So, you ready? Here's my equation. Winner minus loser equals m8. You see how we reasoned that out? I can calculate some of these in a pinch. Usually, certainly if I know what direction, Alicia, the object is accelerating, then I know who the winner is. Since they didn't give me that, I had to do some thinking. You okay with that? Pause for 1 second. We're back. Haley, what did this question want me to find? What letter stands for acceleration in my little equation there? All right, boys and girls, how would I get that A by itself? What's right in front of the A mathematically? And what's the M doing? Adding, subtracting, multiplying, or dividing? So if you had to move it over, what would you do? Congratulations. We're not going to put this I can't come up with every equation, and we can't write them all on our formula sheet. All I can do is I can show you a method. How did you say I would get the M by itself? Nice and loud and proud? So if I hear you correctly, you're saying this. A equals mg minus t all divided by m. Yes? You're right. Okay. And again, Alex, I can't possibly come up with every possible force equation. What I can say is, you know what? If you do a free body diagram, a good free body diagram, if you keep Newton's laws in the back of your mind to make sure that you haven't missed any forces, then winner minus loser equals ma will work. Hey, it's plug and chug. Haley, what was the mass? G is 9.8, not negative 9.8 this time, Courtney. I took care of the direction with my winner minus loser shtick. Minus, what'd you say tension was? And you said the mass was 12. I'm going to encourage all of you to get your calculators out because often I see calculator errors here. Haley, are we dividing? Is there more than one thing on top of the fraction? What would I have to remember then, folks? See how we're coming almost full circle back to September? Yes? So if I'm going to type this in one fell swoop, and I am, I'm going to go like this. Bracket 12, and I'm going to use my times button, 9.8, take away 98, close bracket, divided by 12. There's a built-in error check here. The built-in error check, remember we had to figure out, Haley, what the winner was? If you guessed the wrong winner, you'll know because you get a negative acceleration. That's the universe saying, yeah, you're a loser. I mean, you got the wrong winner and lose, whatever. Do we get that? 1.6333333. Okay. Units, it's acceleration, Sarah. Yeah, oh, if I was a good teacher, I would have told you it's really one of the things that is worth memorizing are what units go with what units. Okay. If you wanted to add a direction, I guess, oh, who did we say was winning? Go look at my first equation. Who did we say was winning? Down. If you wanted to add a direction. This thing's speeding up, going down. You okay, Cohen? Yeah. Fighting a cold? That's all good. Breathe on Adric. Oh, never mind, maybe not. Example 5. Mr. Dewick jumps out of an airplane. I mentioned I jumped out of an airplane. Once he pulls his parachute, air drag has a force of 745 newtons. What's his net acceleration? What does this question want me to find? Acceleration. Did they give me a VI, a VF, a T, and a D? No? Okay, then I think we're going to find acceleration, Trevor, using forces. You know what? This is a job for a good free body diagram. Here's me. Trevor, what were the forces acting on me when I jumped out of an airplane? Get the obvious one. Which way? What else? Once I pulled my parachute, according to this question. Yeah, you. What did I call that parachute force? I used 2 words. We'll call it drag. Okay? Which way? Up. Bigger or smaller or the same size as gravity? You know what? I'm not sure. Could you quickly go mg on your calculator? What do you get? 92 times 9.8, what do you get? Oh, air drag, bigger, smaller, or the same size as gravity?
Smaller.
Okay. Who's winning? Who's the loser? minus equals, what's it always equaled so far? F net, which we said was just what? MA. Trevor, what's this question want me to find? Oh, how to get the A by itself.
Divide it.
Divide what?
Divide by M.
Oh, divide the M over. Because I said how to get the A, and you said divide. It sounds like you said divide the A. Divide the M over, right? Okay. So if I hear you correctly, you're telling me it's going to be the mg would drop down, the minus drag would drop down, and you're telling me that whole thing is going to be divided by m. Yeah, there's the physics of skydiving. What was my mass? Thankfully, I'm a little less than that. 9.8. Mr. Duick, shouldn't you put negative 9.8? Actually, I think this time we decided it was going to be easier to let down be positive. Winner, right? Minus, what was the drag? Yeah, don't I told you. What is it? By the way, air drag is very, very difficult to physically calculate. It's a huge calculus equation. Either I'll tell it to you, or I'll give you everything else so that you can get drag by itself and then crunch it. Okay? What is it this time? 745 newtons? All over 92. What am I accelerating at? Not 9.8, thank God. Have I mentioned lately I jumped out of an airplane? Yeah. Let's see. Again, is there more than one thing on the top, Alex? Mr. Prokop? Oh, brackets, right? You get 1.7? Whew. Now, I'm still accelerating, which means I am still speeding up, which means I am still going to die. But in real life, as I speed up, air drag gets bigger. In fact, I stop accelerating when drag equals mg. Because then it's winner minus loser. Ryan, you know what? Then it's a tie. It's winner minus loser equals 0. We call that terminal velocity. And you can calculate about what speed someone will be at when that happens. And it's survivable. When you hit the ground, it's just like jumping off of... if we stacked about 2 of the tables together, and if I jumped off of that, it's about like that. But we can we can increase our air drag right at the last second. If you've watched skydivers, they change the angle of their chute right before they hit the ground. They fill it with extra air, and they're able to time it. You saw in the video, my guy was really good. We barely bumped it all. Sorry, what 1.7? Is that what I said? Acceleration. Acceleration. Yeah. I'm trying to teach you. Always do your unit check before you move on, right? Okay, let's put it all together. All the stuff that we can now do. Cody jumps from a 4.5 meter high cliff into a lake. 4.5 meters, you know what? That's kind of boring. Let's scribble that out. Let's make it 9 point. You know what? Let's even go better than that. Let me think here. I want a more interesting. Let's go 19.5 meter high cliff. That's pretty high. Assuming his mass is 65 kilograms. A, find how long it takes until he hits the water. Ignore air drag. We're going to assume... I have yet to see cliff jumpers deliberately go into spread eagle skydive belly flop position. Anytime I watch someone jumping into the water, they tuck nice and tight. So we're going to ignore air drag. What's A want me to find? Oh! What else do I know? What is distance? Sorry? Nope. Not 19.5. What? He said negative. Now we got to be more careful. Now we're going to be using T and VF and VI, and now A is going to be negative. I'm not, you notice I haven't done a free body diagram. Someone said mass. I don't think mass is going to make a difference right now. Remember I showed you a video that if we ignore air resistance, all masses fall at the same rate, so we can ignore mass. Certainly I can say negative 19.5. Oh, you know what? I think I know A. I do. Negative 9.8. I know one more thing that I said I would never tell you that we could just assume if you were jumping off of a cliff. VI is what? That should be enough. You know how I know? Because I have three things to find a fourth, which was always our pattern in that particular unit. Which equation has T, D, A, and VI in it? Oh, they're digging up their formula sheet, or they're remembering it, or what? Which one, Andy?
E equals VI T plus 8
And I think now I can safely say to all of you, oh yeah, the quadratic one. I think you guys have all done that now in Math 11, yeah? And you've done the x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, that little thing? Oh, the quadratic formula? You haven't yet? You will. Why can I do that? Okay. So I end up with this. D equals a, and this is, we're jogging the memory from before Christmas, I know that. T squared over 2. Huh? Where'd the over 2 come from? Oh, instead of putting a 1/2 in front, timesing by 1/2, same as dividing by 2, but that looks prettier. Also, what am I trying to find? Well, let's get the t by itself. How would I get the t by itself? What would I do with that there a? What will I do with that a? What? Sorry? Yeah, because what's the a doing to the t? Timesing, so what will I do? Okay. What will I do with that 2? Because right now it's dividing, yes? So if I hear you correctly, and I think I do, you're telling me it's going to be the d just drops down like a domino. A 2 ends up in front of it because you said we're going to times it over, and a ends up below it, and that gives me t squared. T what? T squared. I don't want t squared. Ah. Yes? I think we're good to go now. I think the time till we hit the water is going to be 2 times negative 19.5 divided by negative 9.8 2 times negative 19.5 divided by negative 9.8 equals square root answer button. Oh, almost exactly 2 seconds. 1.99 seconds. That's a fair chunk. 19.5 meters. Most of you, myself included, probably would chicken out at the top because it looks much higher than you realize. And being in free fall for 2 seconds, unless you've jumped out of an airplane, I mentioned I jumped out of an airplane, is pretty intimidating. And somehow I just lost everything. Let's do that. Bring it back. No. I think I have to do this weird thing for some reason. I don't know quite why that happens. It scares me each time. What did I say? 1.99 seconds. Courtney, have we used winner minus loser forces yet? Patience. B says, find his velocity when he hits... Oh, what's B asking me to find? Court? Which one? Yeah. Courtney, did I list everything in the previous question, all my data? So I'm not going to read DFIC. I'm just going to say, hey, can you find me an equation? It's got to have a VF in it. And other stuff. Which one, Rye? You got your formula sheet there. I caught you zoning out. I know my audience. Yes? Find the one with the VF in it. He's hunting. Because all the stuff is fair game on your test from the previous unit, because it's acceleration. Keep going, my friend. You're good. I think you had it. There's an easier one. That'll work, but there's another one that has the VF by itself. Double check. Ryan, do I know VI? Plus, do I know A? And did I just calculate T? And are we confident that we got T right, so we're going to use it because we're lazy and don't feel like doing that squared one? Well, good. Okay. So it's going to be 0 plus negative 9.8 times 1.99. I'm going to, rather than using 1.99, I'm going to use my answer button. Do I, Alex, need to go 0 plus? Will it make a difference? No, I say. It's going to be negative 9.8 times my answer button. What's the negative telling me? He's going down, because this was where down, what last unit, a couple of units, was down was negative. Negative 19.54. You know what? I'll go negative 19.5. I'll carry one extra sig fig. 5.5. Because I think I'm going to use this. Okay. If Cody's feet barely touch the bottom of the pool, which has a depth of 2.5 meters, what was his average acceleration while he was in the water? Okay. Lindsay, what's this question asking me to find? Am I going to go free body diagram, winner minus loser? Here's how you know whether I am or am not going to do that. Have I done any work with forces yet? I might, because I know mg, they did give me the mass, but for now, I'm going to see if I can get the acceleration using my good old DFIC VF VI shtick. Is that okay, Linz? In particular, what did they give me in this question? What piece of information? A distance. That suggests maybe I want to use the acceleration stuff from the beginning of the year. Okay? How deep is the pool? So what am I going to write for the distance? No. He's going down, isn't he? Okay. What else do I know? I think I know this. What's VI right when he hits the water? Alicia, that's why I had to walk through all this. Negative 19.55. The final velocity as he hits the water is the initial velocity when he starts to get slowed down by the water. What else do I know? What? Why? That's I said, just barely touch the bottom of the pool. I think what I'm saying is, just as he touched the bottom of the pool, that's when he came to a stop. Is that okay? Ryan, I'm coming back to you. I'm looking for an equation that has an A, a D, a VI, and a VF. I think it's the first one you read to me. We want to get the A by itself. Okay. What's going to drop down like a domino? Yeah. Keep going, Ryan. Then what? Yes. I love it. Then what? How would I move the 2 and the D over? And do you mind? I'm going to put the A on that side because I like to have the A by itself on the left side because that's what you guys are used to for math. Little nerdy adrenaline rush. Look what I did, mommy. No? Okay. That's pretty good. 0 squared minus negative 19.55 squared. By the way, when I square this negative, what's going to happen to that negative when you square it? I'm not even going to bother typing it. Actually, I'm going to use my answer button. Divided by 2 times negative 2.5. Prith, is there more than one thing on the top? Is there more than one thing on the top?
Yes.
Is there more than one thing on the bottom? What am I going to remember? I think I shall. 0 squared. I probably could have ignored typing that. Minus answer button squared divided by 2. Are you cluing in? If you have an answer button, you can really save yourself a lot of typing if you're clever, yes? Times negative 2.5. Do you all get 76.44? It's an acceleration. It's an acceleration. It's, turn the page. By the way, how many G's? Cody's not happy. He'll survive, but I'm telling you, it would sting. That would hurt, would get your attention. That would be, okay, well, again, part of the problem was I didn't make the pool very deep. 2.5 meters, that's from my feet, 2.5 meters, probably about here. Not a very deep pool. He was stupid to jump into it. I'm not talking about our Cody. I'm just made up a name at random. Honest. But you wouldn't jump into that. What you would want if by the way, you guys can stay here. Can you see Ryan, if the distance got bigger, if the pool was deeper, if the bottom number was bigger, you'd be dividing by a bigger number, and this number here would be smaller. The moral of the story, Courtney, is find out how deep the water is before you jump into it, which again, in hindsight, seems really obvious, but there's the physics. You okay with that, Cohen? Good. Cohen, can you read D to me out loud, please?
What was the net force that the water exerted on?
There's the key phrase. Do you know why that's the key phrase? Because of the word in front of the word force. What's the word, Cohen, in front of the word force?
Net.
You know what? I've told you that F net is just MA. I don't need to go winner minus loop free body, blah, blah, blah. Did they give me the mass? Did I just calculate the A? Yep. Plug and chug. What was the mass? 65? Is that what I said? No? Yes?
Yeah.
Rare beginning of the question. Yeah, 65?
Yeah.
And 76.44? 4,900 and I'll call it 70 newtons. That would get your attention. You'd survive. If you landed wrong, so if you didn't land nice and tucked, you could very likely break a bone on impact with this. Might do that. 2 more, we're done. What does FBD stand for? Free body diagram. Free body diagram, but that's okay. Okay. So draw a free body diagram for a cyclist moving to the right at a constant speed while pedaling. This is why free body diagrams are nice, because I can't draw to save my life. I suck at it. Oh, there's my cyclist. perfect drawing, Mr. Dewick. What are the forces acting on this cyclist? Get the obvious one. Gravity down. Right? I'm going to assume you've all been on a bike. Is the bike sinking into the ground like quicksand? No. Is it flying into the air like Superman? No. So what can you tell me vertically about the forces? This is Newton's first law. There must be another force pointing which way? Up. How big is that force pointing up compared to gravity? Bigger, smaller, or the same size? Has to be the same size. Otherwise, it would be accelerating up or down. That's the usefulness of Newton's first. What force is that? The ground pushes up. Just like when we do push downs, which is really what they should be called. Okay. What else? Is that a student or what? Okay. Okay, I'll be done in 2 seconds. What else? Sure. By the way, are you seeing our notation? We call it F because we want to make sure we know, Lydia, it's a force, and then I just put a subscript describing it, and we'll get shorter, and we'll actually learn names for some of these, and it'll be mostly one-letter subscripts. But for now, I'm writing out the words. What else? What's the force on why is there a force on the left? Not because forces come in pairs. What's my acceleration? 0, which means all of my forces have to be balanced. That's Newton's first. There has to be a force to the left. How long will I draw the arrow compared to the pedal arrow? Bigger, smaller, or same size? What force is that? If you've ridden bike fairly quickly, you actually know what this force is because you feel it. Lydia, this is why you can't go any faster. You pedal. In fact, you know what? Let's call it drag again, since that's what we called it with my parachute. The maximum speed for all of you is you pedal fast enough until the force that you can exert with the pedals exactly cancels out air resistance. And I'm sorry, then you can't possibly go faster on your own. A hill can help. That's a totally different situation. Because now you've tilted and gravity is actually acting in your favor. That's physics 12. As soon as we don't keep things level, either straight up and down or straight flat, physics 12. But for now, all of you have actually done that if you pedaled as fast as you could, and I'm going to assume all of you have done that at least once. Okay. Number 8. Draw a free body diagram from an inline skater, rollerblader, who's dragging the toe of one skate in order to slow down and stop. Okay. There's my skater. What are the forces acting on this skater? Get the obvious one. Do inline skaters sink into the ground like quicksand? Do they fly into the air like Superman? So are they accelerating vertically at all? So there must be an arrow pointing up. How long will I draw that arrow? Bigger, smaller, or the same size as gravity? Next lesson, we'll learn the proper name for the ground. It's called the normal force. What else? Let's assume the skater is moving to the right. What else? Which way? Okay. Do you want to know what force that is? I think it's actually friction between the toe and the ground. So I'm going to call that. What else? Is there anything else? Which direction is this skater rolling? To the right? I don't care about that. Here's what I care about. Which direction is this skater accelerating? What direction is this skater accelerating if it's slowing down? Left. Is it possible for that to have a net force pointing left? Yep. That's it. This bugs people. People want to say, well, no, the skater's moving forwards. There has to be a force forwards. No. It's not which way the skater is moving. It's which way the skater is accelerating. That's it right there. That will slow you. And by the way, those of you that inline skate, that's what you do when you drag your toe to come to a stop. You create an unbalanced force backwards, or in our picture, to the left. I know you're moving forwards. I don't care about that. You're accelerating backwards. Have I convinced you, Court? Is that okay? Anybody here rollerblade? It was really popular for a while, and it's kind of vanishing now. We skateboard now. Okay, whatever. I'm going to tell you your homework, then I got a video to show you. Number one. So number one, the mass is 2 kilograms, and I'm giving you a bunch of tension questions. I really encourage you, do these on a separate piece of paper, not on here, and do a little free body diagram for each situation. You're going to be tempted. You're going to be very tempted to say, no, I can imagine it all in my head. Please trust me. I'm giving you baby step questions right now. I guarantee you it will be so easy for me to add just a couple of things, and you can't do them in your head anymore. But Alicia, if you get good at the free body diagrams on the baby steps, then if I add something, all you're really going to be doing is adding one extra arrow. Meh, that's not a problem. So, number one. Number two. Okay? Number three is algebraic. I haven't talked about this. This is my way of seeing who can figure this out. It says, assume the force F is the only horizontal force on the block. If the first block accelerates at rate A, then find the expression for the unknown acceleration. So here we have F, M, and A. What if we have 2m? What if the mass gets twice as big? What happens to your acceleration? See if you can figure it out. Here we have F, M, and A. What if the force gets twice as big and the mass stays the same? What happens to your acceleration? I'm sneaking some algebra in. Suck it up. Number 4 is good. Number 5 is good. Hey, that's a pretty good cyclist, Mr. Dewick. Yeah, I have a friend who's good at stick figure drawings. 6 is good. 7 is good. Are you just going to assign everything, Mr. Dewick? Yep. 8 and 9. Matt, what's your acceleration right now? Are you sitting still right now? Well, technically, no. Because of what? How long has the Earth been moving?
A long time.
Why doesn't it stop? That's the question. Why hasn't the Earth slowed down and come to a stop?